Hello, Mr. Betts here. I'd like to take a look at a couple of kind of uncommon examples with geometric series. In these examples, what's happening here is we're given the sum of a geometric series, and we want to figure out what that series is going to look like. So if we know that the sum of a geometric series is going to be 1 over 1 minus x, essentially what we want to do is we want to match that up with the sum formula, which we know is the first term over 1 minus the common ratio. Now, this is a pretty straightforward one. If we want to make this sum in the problem look like that formula, we can do that by just making a couple of simple substitutions. We can say the first term is 1. We can say the common ratio is x, and that's going to do it. So this geometric series is going to look like this. Its first term is 1. Common ratio, we're going to multiply by x each time. So 1 times x is x times x is x squared times x is x cubed. And so our geometric series is going to look like this. It does say in the problem that we want to write our answer in sigma notation. So I want to write a sum in sigma notation that looks something like this. So notice that each term is of the form x to some power. Those powers actually start at x to the 0 power with the 1. So I'm going to say k starts out at 0 and goes to infinity. And there you have it. That's a geometric series. And that geometric series is going to have that as a sum, assuming that it converges. So the second part of this says, for what values of x will the series converge? In order to do that, we need the common ratio to be between -1 and 1. This is, again, pretty straightforward. Since the common ratio is x, we can just say -1 is less than x is less than 1. And so this series will converge as long as x is between -1 and 1, because we know what the sum formula is. A little bit more complicated example might look like this. So if I want the sum formula to look like this, x over y squared, remember it's the first term over 1 minus the common ratio, a fairly straightforward way to do it, and I want to say this is not the only way to do it, but a fairly straightforward way to do it is just say a is the first term, and I'm going to use a different color here, y squared is going to be 1 minus r. So if we say a is the first term, we can say a naught is x, and then we can say we'll have to set up an equation here. 1 minus r is equal to y squared. And if we do that, we want to solve for r. We get r is equal to 1 minus y squared. Okay, now these two things here will allow us to build our geometric series. Essentially, what that geometric series is going to look like if we write out terms is the first term plus x times 1 minus y squared to the first power plus x times 1 minus y squared to the second power, and so on. Kind of ugly, but it works, and this sum is going to have a sum. This series is going to have a sum x over y squared, as assuming that the series actually converges. So we do need to show the series converges by saying that the common ratio is between -1 and 1 and figuring out what values will make that happen. So to make that happen here, we're going to have to say -1 is less than 1 minus y squared is less than +1, and we want to solve this inequality. So we subtract 1 from each part, we get -2 is less than the opposite of y squared is less than 0. Divide by -1. Now keep in mind, dividing by a negative number is going to make negatives positive and positives negative. So essentially we're flipping the number line, which means we need to flip our inequality. So we're going to have 2 is greater than y squared is greater than 0. And then we take the square root. Square root does not change the order of numbers. So if we take the square root of a bigger number, it's going to stay bigger, so we don't have to worry about flipping. So taking the square root of each part, we have the square root of 2 is greater than y is greater than 0. And generally we want to write our inequalities from least to greatest. So rewriting that, we're going to have 0 is less than y is less than the square root of 2. So as long as y is between 0 and the square root of 2, no matter what starting value we have, we're going to get a geometric series that converges and has a sum of x over y squared. Now, I skipped to the conditions part, but we do need to write our answer for the geometric series in sigma notation. So I'm going to start at 0. We're going to go to infinity. And the standard form here we can just say x times the common ratio. So first term is x. Common ratio is 1 minus y squared. And we're going to raise that common ratio to the k power. So when k is 0, this is going to be 1, and the first term is just going to be x. And then each time k increases by 1, we're going to be multiplying by 1 minus y squared one additional time. So this geometric series will converge for values of y between 0 and the square root of 2, and we'll have a sum of x over y squared. It's not immediately obvious how this could be useful, but for some reason, if we wanted to make a geometric series have a certain sum, this kind of process could allow us to do that.